be awful.
Hello, everybody.
It got postponed.
So welcome to my belated robot presentation. I've been working on this robot for off and on for probably a couple of years, which is kind of ridiculous because it could have been a lot shorter than that if I really worked on it a lot, but it took a lot of time. So anyway, I want to show off my Mailbot named Cliff. My name's Gary Simone. Oops.
Oh, it turned off.
There we go. Gary Samato is one of the founders of the Robotics Club, and just been working on different projects over time, and so it's finally a good time to demo this robot, which is half done. It's kind of half done because it does the final stage of what it has to do without doing one of the early stages, and I'll talk about that some more as we go along. So I thought I'd sort of talk about the process and some of the problems I found and show what the robot does and also talk a little bit about the mailbox. But I want to ask, how many people already seen my mailbox presentation, which I did about 6 months ago? Raise your hands. 6, 8. So still a lot of people haven't. Okay, so I won't talk too much about the mailbox, but I'll talk about it some, and if you have questions about it, it's actually pretty cool too, and it's actually working. The mailbox is actually living in the wild. You can see, if you look at the top of the mailbox, the bird poop on it and stuff. This mailbox is real, and it's actually been working for 9 months now in the field. It's an internet-connected, solar-powered, voice-enabled mailbox. Kind of ridiculous, over-engineered, but whatever. That was part of the fun of it. Yeah, no, it's totally fun. And this is my Mailbot named Cliff. So I was just talking to someone earlier about, how many people know Cliff from Cheers?
Oh.
Mostly old people. Exactly. Well, this Mailbot is named after Cliff from Cheers, who was a mailman who was always, on Cheers and Brew Bar. And yeah. So whatever. It's casually I named him Cliff, and so whatever. So let me tell you. I don't have a whiteboard, but that's okay. So let me tell you what the goal of this project was and is, and sort of where I went on building it, and then I'll talk technical later on, sort of more technical on how it's built, but also the process of just where it's gone is kind of cool. So I live on the top of a mountain, and I have a private road that's, I keep saying it's a quarter mile. It's actually a quarter mile round trip. So my road is like 1/8 of a mile, drops 100 feet in elevation. And my mailbox is way down at the road, the bottom of the road. So to get my mail, or to even know if I have mail, I've got to go and get my car and drive. I mean, you can walk, but it's a long way. And when I come home, you don't know if there's mail in the mailbox. So you get out of the car, you have to go and check, the mail's not here yet. So I decided I wanted to build a robot to get the mail. So that was my primary goal. And this was probably 2 or 3 years ago I thought about this idea and started building it maybe a couple of years ago. So I was like, let's build a robot to go down and get the mail. So I started, originally I joined MakerPlace. I don't know how many of you guys know about MakerPlace, which is a great, it's a place that you can join. It's like $100 a month. It's not cheap, but they have tons of tools, machine tools, and so on for machining wood, aluminum, painting. They have laser cutters. They have all kinds of stuff. So I joined there and started learning how to machine aluminum in order to build this robot. So I ended up working there for a few months, learning how to mill stuff, learning how to build stuff, and I basically built the base of the robot, but I kind of stalled out because it was like a half an hour to drive there, and then a half an hour to get home. And once you get there, you have to set up all of your equipment because the last guy that was using the machines, didn't have it set up the same way you did. So it was just like kind of a real hassle. So this is a great excuse to build a machine shop at home. so last summer I built a machine shop at home, which is cool, and my wife is great about it. So I love that. So that finally got me going again to work on the robot some more. But in the meantime, I kind of stalled out, sort of working on the base of the robot. The idea was there, but I wasn't getting much done. So I decided to go and do a partial solution, which turned out to be the mailbox itself, which at least the mail doesn't come up to the house, but it alerts me when there's mail, and it detects mail, and it talks and stuff, which is kind of cool. So I did that in the meantime, and then I finally set a deadline. 2 weeks ago, I did a presentation for Mensa Science Group, and then tonight, and that forced me to get this finished, at least finished in the sense of doing the final stage of retrieving the mail. So let me talk about basically the goal of how it works. And there's beer here. You guys grab beer. I see one's missing, so someone took some.
I got some.
So,
Thank you.
okay, good. I always bring good beer when I do a presentation. It makes my presentation, you guys think my presentation's better. Yeah, good. Good IPA, Racer 5. So anyway, so I thought about when, you think about doing the project, I thought about how do you go get the mail? Open the mailbox, reach in, pull mail out, that kind of stuff, way too complicated. So in just sort of walking on the beach in Torrey Pines every day for a while, I sort of thought about how do you do it, how do you keep it simple, and I thought, well, the simplest way I came up with as an engineer was to bring the mailbox home. Don't get the mail out of the mailbox, go get the mailbox and actually bring the mailbox itself. So that was actually, that actually is what the direction I pursued. So let me just sort of demo it, and then we'll go from there. So imagine, this is a mailbox. This isn't going to be the final mailbox. This is my current mailbox. So imagine the mailbox is sitting here. So this is the platform that's just simulating the mailbox. This is for my testing purposes. But there will be a mailbox mounted on a platform just like this. Okay, so this is the mailbox sitting down at the street. Now the robot not only can bring the mail up, but it can take the mail down. So again, I've only built half of it right now, the one portion that can manipulate the mailbox. But the reason it's designed like this is because everything that's on this side is also going to be on that side, so that there will be one mailbox up at the house, and if you have outgoing mail, put it in the mailbox at the house. The mailbot drives down, picks up the outgoing mailbox, spins around, drops off. Picks up the incoming mailbox, spins around, drops off the outgoing mailbox, and comes back home. So there are two mailboxes, one that's always down at the street and one that's always up at the house. So here's the basic final manipulation that took way more time and effort than you'd think. And we'll talk about it some, after it's navigated itself down the street and to go and pick up the mailbox. So here we go. So actually, part of this project, I found this really cool, ridiculously cheap. This turned out to be like $15 remote control device so I can play around and do stuff. So basically, mailbox drives up, grabs it, lifts it, drives back home. May not look like much, but it was not easy to get it to do that. And so then drop it off. So now it would spin around normally and drop off the other one. So, but in this case, come up, drop it off. Unfortunately, I had to touch it. I didn't have to, but I didn't want to get crazy. So whatever, there it is. That's the basic end game of the robot picking up the mailbox and driving it back home. And so I'll talk a little bit. Actually, let me just align this a little bit better, just for the heck of it. Let's just try it again, just because I want to see. It's actually using some sensors to detect that it's actually contacted mailbox. So you'll see there are like a few actuators. There are the motor actuators, the linear actuator here for raising it. There's actually an actuator right here, a servo, that you can see that's grabbing the mailbox, and that's actually really helping to stabilize it. And then there are actually a couple of sensors. There are some touch sensors both down here at the bottom. and up at the top, so it can actually detect when it reaches the end. So it's actually a closed loop. It'll drive forward until it detects that it's actually touched both the mailbox and the base before it actually does anything.
Is that some kind of magnet on the little arm that's on the servo? Or like
No,
is
it's
that,
just-
is that
it's
just
a
a
hook.
bumper? Okay.
Yeah,
I
just
got
a
it.
hook.
Sorry, this? Yeah, that's the
Okay.
whole servo itself. So basically, that's the operation. It's actually fairly robust as far as being able to, find that it's actually reached its goal and then go and manipulate it, and then, but I don't know. This is the state it's in. So
How
let's.
do you know that there was a mail?
Sorry,
How do you know there was a mail?
that there was mail.
Yeah.
Well, okay, I can lead into talking about the mailbox if you'd like instead, or head off in this direction.
We'll talk about it later if you want to finish the robot part.
Okay, so we'll talk about the mailbox
Because I'm
later.
interested in hearing about that.
Yeah, because this is internet connected. So
Can the robot? Does it orient itself? Right now it's like a straight line.
right now it's pretty. The navigation is mostly open loop. It just does the basic drive forward until it's actually closed loop.
Is it going to be line following?
It's either going to be line following or GPS enabled, or something else, and I can talk about that a little bit too.
Yeah.
But so there are basically two phases to this whole project. So there's the navigation phase, getting from the house all the way down to the mailbox, and then aligning itself to the mailbox. And I have several thoughts about using video to align, but line following, and there are other possibilities too. And then there's the final manipulation. So I finally got the final manipulation part sort of good enough to demo, which is what I brought today. And actually demoing the navigation part is not even going to be possible to do here, probably. So in a few months, I'll have you out to my house, maybe, and actually demo it actually at my house. A few months. Okay, write that down. Let's see.
Where's my calendar here?
I know. So now, what is the date?
When did you start this project?
Oh, I probably started thinking about it about 3 years ago, maybe. Then I started building it probably 2 years ago, and then I kind of stalled out, like I said, and didn't do anything for maybe a year. So I built my own shop at home, and by having my own shop at home now, it's great because now I can go out.
Rid of the excuses.
What's that?
You're getting rid of the excuses.
I am getting rid of the excuses, exactly. I'm not an excuse kind of guy. I actually like to get stuff done. So now, if I want to go out and work for an hour in the evening, I can just do it. And everything's all set up already. And I've already got the right kinds of screws and the right sizes of drill bits, and all the things are already set up. So I can go out with my drill press and make something happen. And I've got an electronics lab I built up now too with actually some really cool things that just for the hell of it I was going to show. This is an oscilloscope. It's amazing. This was like $80. And this is really cool too. So I've built up an electronics lab also. So now it's a lot easier to go out and keep making progress and not having to spend an hour and a half getting set up to do something. I can just go out and work in the garage and work in there.
So Gary, how are you going to rotate that around? Are you going to have the post rotate or the whole robot rotate?
That's a good question. Originally, when I designed it, I thought about having a servo on the top and spin the top. But then, as an engineer, I'm like, keep it simple. How can I eliminate the servo? Hey, it already knows how to drive.
Oh, so you can just turn it on. Oh, okay.
Not particularly. I was just playing around with this yesterday, just getting it to spin. But basically, the idea is that it's just going to be able to spin on its own.
Seems to me that's perfect for a vision system.
Yeah.
You could paint the post with something that it can see really well.
Exactly. Or use reflectors.
And that way you could have it not hit cars in case somebody's driving up your driveway.
Well, that's actually one of the big issues, and I'm probably going to use. I'd
maybe
like
have
to
somebody
use.
drive over the edge of it, and there goes your robot.
Yeah, I'd like to use LiDAR, but LiDAR is really expensive still.
Doesn't work at night, at daylight.
No, it can. Yeah. I was just up at the DARPA robotics competition. They're all using LiDAR, but it's expensive, like $5,000, $10,000. But there are some cheaper ones that don't seem to work as well. So that would be nice to really be able to map the environment. I'll probably end up using sonar. You can get really cheap sonar sensors for like $5 that'll tell you if there's something in front of you. So if the FedEx truck is coming, they'll be able to stop. Yeah.
When
on down one of the sides and just pull.
That's true, and I actually have already built a system that can do that and follow lines, and I may still do that eventually, but I'm just want to learn something new. Part of the fun of this project is to try something different. So I've already done successful line following, and that's a perfectly good way to do it. But I'm going to try to use GPS and video just to learn a new way to do it.
Why can't you just take apart a camera to get a free little? Why can't you just take apart a camera so you can get one that you can mount on that?
Yeah, actually, I am going to use a camera probably, and I'm using a cell phone camera. So the cell phone is actually ultimately going to be the ultimate brain of this. So it has a camera, it has GPS, it has accelerometers, it has a lot of capabilities, it has the ability to communicate. So yeah, so the cell phone is actually ultimately the main brain. But to do this final part, I didn't need it. I just needed an Arduino to do it.
Will the GPS receiver on a cell phone be accurate enough for what you need?
Boy, I should have planted you guys in the audience. This is a high resolution GPS receiver that I just started playing with. I actually bought one. It's a Garmin. It's like $100. And I use this for racing. When I race my Porsche, this ties into through Bluetooth to the phone, and I have apps that will show your map of your racing line, and it'll actually show you lap after lap your racing line. And it's accurate enough to be able to tell whether you're on the outside of the corner and the inside of the corner from lap to lap, which is really amazing that it's that precise. And I started researching it just a few days ago again in detail to thinking about this project. And it turns out that one of the reasons that this particular Garmin is really precise is it doesn't only use the United States GPS system, it uses the Russian GLONASS also. So there are 24 more satellites that it actually uses. And so apparently it's much more precise than you would typically get. So again, I just started doing experiments with that to see if it's going to be good enough for driving down the street, but it's good enough for racing.
Out of curiosity, what is the accuracy in meters on that Garmin unit?
Well, that's the thing. I need to really find out, and I believe in software that you can get the current accuracy, which is going to be key. So you can actually look and say, hey, the accuracy is not good enough right now. Just stop or slow down and don't be crazy. And if the accuracy is good enough, then go ahead and continue. But normal accuracy can be as good as 2 meters with just regular GPS, which is 60. And then with this, it seems like it's better, but I can't tell you the numbers yet.
Have you looked into using like a RFID sticker or tag on the mailbox?
You mean for what purpose?
For location. So like once it's close enough to like.
I haven't thought about that. How, is that good? Will that give you?
Really close for that, right?
I don't know. I think it works at. Well, I mean, not inches. I mean, I don't know how far it goes. I'm just curious.
Okay.
You know,
I actually
I see
haven't
like
thought
people
about
doing that,
that.
like putting like RFID stickers on objects to locate them later.
Oh.
Do you think to be precise enough to navigate to it? You mean from?
Well, I mean, it wouldn't work from your house,
Right,
but like
right.
once you're like
Near, yeah, there's going to be a
10
final
feet or
stage.
something like that. Then yeah, I think it could like help.
I think you just get sort of like, am I in a certain range of it? It's the more sophisticated stuff that 5D robotics will show uses more sophisticated, time of flight from 3 or more signals using RFID systems that's more accurate. And they get to 2 centimeters. But I think the stuff that you get.
But from what distance is the question?
Well, I think in line of sight, I think it's hundreds of feet.
Oh, really?
It's quite good, yeah. I mean, so they're using pro stuff. I think they're presenting that soon.
The Roomba just uses IR, and it finds its way back to the base station pretty well.
Right.
Outside sunlight.
Yeah, and IR is probably fine. Or even line following at the end, after it's done the navigation all the way down, to some final line following, or a reflector here with a video blob location. So there are lots of sort of end stage ways to, I think, finish the job.
That's the exciting part. We're excited too.
No, it's cool.
I know.
No, it's totally good. Throw out ideas. So, yeah.
So then the idea is when the mail comes, you just turn it on and let it do its thing.
Or it'll turn itself on, which this mailbox, when it's opened and it knows there's mail, it actually logs onto the internet, updates my website, and sends me a text.
Okay.
So,
It sends in a friendly voice, You've got mail.
You joke. It actually does. Boy, it's like a plant in the audience. Sure,
Where's my
yes.
$50?
Yes.
Has the mailman freaked out yet?
The mailman loves it. In fact, yeah, I've talked to the mailman and stuff. And I worried at first that he might freak out, terrorism, this and that. But he loves it. And in fact, this has actually been living in the wild out for 9 months now, flawlessly. The mailbox itself has been basically flawless. The only failures I've had have actually been internet infrastructure failures, Wi-Fi infrastructure failures, which is interesting. But the mailbox ran flawlessly until about 2 weeks ago when my solar-powered battery died. And I saw the mailman, and he's like, "Hey, your mailbox isn't working. Come on." So the mailman loves it.
So you brought that, what, a year ago, that battery?
Yeah. And in fact, I was just under a year, and a 1-year warranty. I contacted them. They sent me a free one.
Really?
So this is the new free one that they sent me. So I'm totally
So
happy
that's
with these
just
guys.
a
So, yeah.
solar powered battery?
Yeah, this is a solar powered battery.
So everyone thinks it's a cell
Yeah.
They do.
Yeah.
And some kids
It looks-
stole the thing. Right after I replaced it, after like about 2 weeks ago, I replaced it, and some kids stole the damn thing. I figured it was, they did some weird vandalism in our house. It was kind of weird, and they stole the battery. But luckily, they didn't realize that the really valuable stuff's in here. This was only $20. I could replace that. So they didn't steal the
You put a
electronics.
camera on it, use security system for your
Yeah.
mailbox.
Yeah, well, I did go now and I bought a sign now that says, "Smile, you're on camera," and then I mounted up even though I don't have any cameras.
So tampering with the mailbox is a federal offense,
Yeah.
right?
Oh, that's right. Someone did say that lately too, and I bet that's
So
interesting.
you can't stand in the way of it as when it's going home, you have to
So is the battery unit in the solar panel? Is
Yeah.
it all one thing?
Yeah, this is a great thing. It's $20. You can get it on Amazon today. It's like a 7,200 milliamp hour. Yeah, 7,200
does it
LiPo
take to
battery.
I got my new one yesterday, $15. I got 2 of them.
Okay.
And it's 30,000 milliampere hours, they say.
Wow.
You mean 3,000?
No, 30,000.
That's what it says
Yeah,
on
they-
That's
they-
insane.
For 15?
I know, but they said
I don't believe it.
it said 16, 1.6.
That's
no,
what
16
Gary, I've got
Maybe.
one too, and I don't believe it either.
Yeah,
No, I
maybe.
haven't had it either, but I have seen
Wow.
people
How
say
long
they
does-
tested it and it was 16,000 milliampere hours.
How long does it take to charge that battery up?
Well, that's the interesting thing. Well, one of the big things I had to deal with on this project is reducing power consumption, right, is the key. So it's gotten to a point, I reduced the power consumption enough that this charges itself up to four bars, and now it doesn't even report that it's charging anymore because, in fact, it's fully charged all the time. But yeah, it's not fast. So if you really start it all the way down, it takes days. It takes days to charge it all the way up, maybe a week.
Did you luck out? Are you southerly facing? Or
Yeah.
did you?
My house is perfect. I've got solar panels on my roof. I've got solar hot water for my pool. I got solar powered mailbox. No, it's perfect. My house is south facing. Yeah.
So why didn't the flag pop out when you opened the door?
That's because it was it assumed that there was already mail and I was retrieving it.
Oh.
So depending on I don't know what mode it's in now. Let's see. Okay, so basically now would be the base mode where the mailman comes, and so mailman puts the mail in.
Yep.
It thanks the mailman and throws out the flag. So that's when the mailman comes. And then I set it. I could have had it automatically retract, but I have it set to manually retract because I didn't want false positives, I guess. So then just retracts when you.
So the flag indicates that there's mail in.
Yes. So when I drive up, even if I didn't look at my text, or my wife didn't get the text, she drives home. As soon as you drive up, you know there's mail. So the flag shows you that there's mail. And
where's the flag to tell the mailman there's?
Nope. So tell me.
No, but don't you need
Is
one?
there a flag
No,
to tell
I stopped using that years ago when I heard that people would go around the neighborhoods and look for flags that were up and steal people's mail. So I never use outgoing flags. I put outgoing mail in the mailbox, but I never use the outgoing flag. In fact, I took it off. I think it came. Yeah, in fact, I put the sticker over it. But there was actually this flag actually was on the mailbox when I took it off.
So your mailman checks it every day to see if, okay.
Yeah, he always knows about outgoing mail.
I mean, the mailman's probably opening the box every day anyway, right?
Yeah.
I mean, more or
It
less.
depends who you, I mean, I don't get mail every day.
Yeah, I mean,
You don't
I
get
do.
junk mail every day?
No, I
Yeah.
What's your secret?
What's your address? I could sell that address.
No, I totally do. And I actually had to talk him into, though, sometimes if there's a big package that doesn't fit, he drives it up to my house and then didn't used to check the mail. So I got him to, like, always check for outgoing mail, because even if you drop stuff up at my house. So that's not a problem. Yeah, so that flag, yeah, so that's mode-based. It depends if it throws the flag in the mail.
Can you walk us through this? I'd like to see it. I'd like to see how everything works with this.
Okay, yeah. So sure. Talk about the mailbox. Do you or so there's we can talk about technical aspects of this too,
yeah.
just if you want, and about the actuators and how everything's done on that. What do you guys think? Or so let's see. Do you want to know more about the right now about the Mailbot or the mailbox? Raise your hand if you want to know more about the Mailbot.
I don't know about your sensor.
Okay, and raise your hand if you want to know more about the mailbox. All right, so we'll do the bot first, and then later we can talk about the box. Okay, so this is as simple as I could make it. So I'm a software engineer, and part of the fun of this project has been learning way more than I ever wanted to know about electrical engineering and mechanical engineering. So machining stuff and building electrical parts and dealing with power and everything. But I wanted to minimize as an engineer in general. You want to make things as simple as possible. The simpler, the fewer things there are that can break. So this is really down to just 4 actuators and 2 sensors. There will be more later, of course, because I have to detect the FedEx guy, and as I add GPS and all that. But for the basic final manipulation, I got it down to just 4 actuators and 2 sensors. So the actuators are motors, right? So there are 2. In fact, let me put this up. This is a good time now to put this up here so that you guys can see. It's fairly robust. I mean, I can set it down on its side, and I tried to build it so that it was going to survive.
Where'd you get your wheels? Your back wheels?
Yeah, Andy Mark. That's the name of a company that builds these wheels. Are the first robotics competition. I don't know if you guys are familiar with that. It's a big high school robotics competition. These wheels are the wheels you get with your robotics kits that are super cheap, like, I don't know, $5 or something. Really, really cheap. And these are really, really cool. I can tell you guys about these. These are called Omni wheels that allows the robot to rotate. So actually, well, I mean, now that we're talking about it, let's talk about it. So this is a differential drive, all right? So the robot drives with 2 wheels. So it's not, there's an Ackerman drive, which is the way your car works, right? When you drive your car, the front wheels turn, and to parallel park, you need to back up, and your car can't rotate in a circle. But with differential drive, both wheels are controlled separately. So the robot can actually spin in place. If one wheel drives forward and the other wheel drives backward, actually that's what I kind of showed before, you can actually make the robot turn in place. So it's very, very maneuverable. But the problem with this drive is if you have your rear wheels drag on the ground. So there's a lot of friction. So there are a few solutions. I mean, you can put a caster on there, but that turns out to be pretty lousy most of the time, like a shopping cart caster. But this solution is great. These are called Omni wheels. These wheels move forward like normal, and they can turn sideways with basically no friction. So your robot can actually literally turn in place without friction, with very little friction on the rear wheels. And these are from Andy Mark II. These were a lot more expensive, the Omni wheels. I don't remember, maybe something like $20 or $30 for wheels this large. You can get smaller ones that are a lot cheaper. But this is another kind of really cool wheel. Just one of the choices to make. driving the robot. And there's another kind called mechanism wheels, which are wheels that actually have 45-degree angle sort of rollers on them. And with those, you can actually make a robot that drives sideways. It can actually drive in 2 dimensions in any way you want to go, which are really cool. So those are kind of your 3 choices. There are tank treads too, but tank treads are the same as this fundamentally.
I know there's this robotics competition for, I don't know what grades, and they give you a robotics kit, and it kind of looks like that, kind of the same objective, but instead it's like recycling bins.
I'm exactly using, you were talking about the Tetrix kit that's used for middle school. I'm using exactly some of those parts. In fact, these wheels are the motors, and if you look closely, you'll see I'm using exactly those same parts.
Yeah, I noticed that, and I saw there were similar
Yeah, no, it's totally cool. I mean, I love that kit, and I'm using the axles from that kit also, and I use as many pieces, and the servos from that kit. I use as many pieces as I can. Problem is, once you start building big things, it's really expensive because that kit's about $600 to start with, which is fine for all the stuff you get. But when you start building things of any size, like one 12-inch section is like $12. So you start, it starts being, $100 or to build something where you can buy a piece of aluminum that's 8 feet tall for like, $5 or $10 or something like that, maybe $10, and then cut it and build. So that's so what I do is I use the parts from that kit when I can, and then I machine things out of aluminum to keep the cost down for the rest.
Are you worried about traction with those front wheels going
Possibly.
up and down the hill?
Possibly, yeah. I'll experiment when the time comes and see. From the beginning, I thought about using pneumatic wheels.
Yeah, that's what I was going to say.
Yeah, so if I have to, I'll go with pneumatic wheels. And this might also be a problem with just bumpiness.
Yeah, exactly.
Because it's so rigid. So I may get pneumatic wheels later. But
What do you mean
I
pneumatic
have
wheels?
air. So if I have to, I'll do that. But I always, it's like if you have the parts and it basically works, and just use what you have, and then upgrade as you have to. So that's why I started with these.
If you're going to put cameras, you should put 360 cameras so the kids still try to knock over the robot.
I have definitely thought about people stealing this robot, because this is going to be like a $10,000 robot, and not counting my time.
Yeah.
Exactly. So I am. The phone has accelerometers in it, so I can tell if someone's picking it up, moving it around. So I'm planning to put in alerts saying, "Step away from the robot," if someone tries to pick it up. And if I decide ultimately to pay for cell phone service for it, I can have it actually sending telemetry back. So if someone actually does steal it, it will know its GPS location, so it can actually report back to me where it is if someone's stolen it. So I have definitely thought about that. Okay.
And it's just Arduino in there.
This is just an Arduino. So let me just show you. It's a little bit of packaging. So part of the fun in doing this project, I'm a software engineer, so I tend to,
But it's a Mega.
What's that? This is a Mega, yeah. So basically, I'm really good at writing software, and I've had to learn a lot of this project on, electrical engineering, mechanical engineering, and so on. So, and one of the other interesting parts of this is packaging. So I want to talk about that a little bit more. I'll just put this out here just to remind us about talking about packaging. But one of the things that you learn is, as I'm building stuff, I've got these boards sitting all over the bench, and I've got wires draped all over the place, and I'm getting things to work, but it's, to get it to something that's real that I can actually bring here and show, you got to package things nicely. So I actually spent a lot of time a couple weeks ago packaging all of this electronics down into a nice little, you want it to be in an enclosure, right? So you've got to build it in a way that's going to survive the outdoors, but also in a way that's accessible to work on it, because you're constantly changing things or trying things or whatever. So I built it all together into this nice little package, put a handle on it. It's kind of cool. And
I know.
yeah, exactly. No, it's great. It's a Tetris.
I was like, what is this running on?
This is totally just a handle for doing exactly what I just did to get it out and work on it.
Of course, it's made out of titanium.
It's titanium.
Yeah, there you go.
This is from the Tetrix kit we were just talking about, actually, this thing. So anyway, yeah, so the whole thing runs on, so there's some high power and some low power stuff in here, which is part of what made this project pretty interesting too, because if you just do a simple project with an Arduino and you're blinking some lights or moving some little things, it's fine, you don't have to think about high power much. But I had to think about high power a lot in this project because, you know, it's like this takes 5 amps. These motors can take up to 10 amps of power. Most electronics are 5-volt electronics, so it's a pretty common system that you would use 5 volts, but a lot of the big power things use 12 volts. So I've got like basically 2 power systems in here. So there's an Arduino, which is a microcontroller. Those of you who don't know, microcontroller that has lots of input and outputs and you know, the brains of the computer. Then there's, in this case, the power, I've got this sort of power grid over here of 12 volts. So this is where I just tie in. You got to have wires that are big enough, and you know, a 12-volt rail basically. And then I've got some big relays here, which are used for switching things. One of the problems with power when you're dealing with a system like this is that a lot of times things just suck power for no reason when you're not really using them. And so a lot of what I learned, especially on that project, is you gotta cut the power out. Like really, literally turn the power off when things aren't needed. So I've got a set of 4 relays here that I use for just cutting the power completely off for some of these big power sources when they're not being used. And there's another set here of big relays that actually just came with a nice little remote control, which again was like 10 or 15 bucks. It's amazing. But it's got these 4 big power relays that I think you can actually run. You can run 110 volt AC off of them if you want. So you can actually power stuff in your house if you want off of these.
Quick question: how large a battery do you think you will need to have enough energy to go a quarter mile down a hill and then a quarter mile back up a hill?
Okay, the battery I have here, which is kind of a little hard to show because if I turn things over, I always want to mount your weight down low, so my battery is as low as possible. So basically, the battery I have here is it's like a 12 volt, 3800 milliamp battery. That's pretty good for what it's doing now, and I can, you know, add more if I have to later. But will need to deal with charging later.
Yes.
So what I'm planning to do, originally I thought about have it drive up and plug itself in, right? That's the cool thing. But that's way too much of a pain in the ass. Now you just use.
Is that battery sufficient to do a half mile and 100 feet?
We'll find out. I haven't tried it yet. So if not, I can, you know, throw more batteries on. It's not a problem to add batteries.
What's the chemistry?
This is, I think this one's a nickel metal hydride.
Oh, okay.
What was your solution though for the not driving for charging?
Yeah, so for charging, I'm going to use inductive charging. Yeah. So like, I don't know how many of you guys have a phone like this now that you don't have to plug in anymore to charge it. You just lay it down on this little device and it inductively charges. And so I'm planning to do that with this. So I'm just going to have it drive up and either drive up with, you know, against the garage with an inductive charger here, or one on the ground that'll just drive over to charge.
I saw a demo at iPress that was like wireless charging, you know, so like you put a little receiver on your robot, and then like if you're anywhere within like 3 or 4 feet of the charging station, it'll like wirelessly charge.
Really? 3 or 4 feet? That's significant. Because I mean, usually you need to be within 6 inches.
It's at a distance, definitely. Yeah.
Mm.
Cool.
I can charge a lot of things like water pipes.
Yeah, and aluminum structures.
So I plan to use inductive charging ultimately. And battery size doesn't really matter that much just because you can always just put more batteries and just put them down low. And so these so far are adequate for the kind of
more batteries you put, the longer it's going to take to charge.
That's true. But if you think about it, this thing's going to drive for like what, 15 minutes a day, that's going to charge for 20 hours, 23 hours, 45 minutes. So, yeah.
It's
So,
not charging off solar. Well, maybe
right, this one isn't, right? This is a different issue. But yeah, no,
Since it's
exactly.
such a heavy frame, you could always use, the lead acid.
It's something bigger if I needed to, yeah.
But
So I
a
don't,
40 or 50 mile an hour wind gust, you don't want to just tip over with 2 mailboxes or one on it.
yeah. So I don't know. I mean, I haven't done
Gives
real
you more
world
traction.
testing.
Put that weights in the bottom too, make it harder to steal.
Yeah.
Well,
Just electrify the
yeah,
frame.
I know.
I like that idea.
Warning, 10,000 ohms.
Yes.
If you put too much weight on the bottom though, then it might go too fast.
Probably not, because I'm completely controlling the amount of power going to the wheels. So it's never going to be able to just like run down the hill on its own. But so weight. So generally, I want to have less weight. I tend to want to have less weight because that uses less battery power. So in this case, I think that's not a problem.
Well, going downhill, you could generate.
Actually, and it actually turns out you're right. It's funny you would say that, but no, actually
Power.
the controller I have does that. And the weird thing is, as I was rolling this in here today, I see an LED turning on. So it's actually regenerating power.
It's
as-
out DC.
yeah. So
Do you have tacks on the motors?
have what?
Tachometers on the motor?
I actually do have encoders on these, just because I happen to use them in a previous project, but I'm not currently using them.
Okay.
But if I need to, I can use them, and those are ridiculously expensive. I mean, I think I spent like $80 each
Wow.
for the two encoders. It was crazy, but I got them and they worked great.
How did you pick the motors?
I just had them
Okay.
because I got them in the Tetrix kit that I had bought previously.
Yeah.
So
Those are, you get one stepper motor for each wheel, and then
They're
you
not
got,
steppers,
are, you,
though, are
are
they?
those steppers?
no,
they're
no,
DC.
these are brushless.
Brushless, right?
Brush
Brushless or
Are you-
brushless.
Probably
So,
Are you
They're
using
both
separate
brushed, probably.
motor control
Yeah.
boards?
Yeah, I did buy a separate motor control board.
it's too easy not to.
So I send PWM signals from the Arduino to the board, and then it
What kind of Arduino board is it?
okay, so yeah, okay, well, so good. So let's get down to the technical. So yeah, so the Arduino is a Mega. And again, a lot of this stuff is like I have it. I've got a pile of Arduinos. It's like pick one that works. And Arduino Mega, Mega. This is actually a Mega 80K. There's actually another reason to use this, because this is specifically designed to connect to a cell phone. So you have to have two USB ports on your Arduino to talk to a cell phone. One talks to a computer. The other one can talk to the phone. So I specifically designed it to do that. But it also comes, it's very powerful. It has like 54 I/O channels. It's really super powerful, way more than I need. Although I'm using a fair number. I'm probably using, I don't know, 15 channels or something maybe. But I could run on probably a less powerful Arduino. But this one is good. I had it, it's, yeah, just use it. So the Arduino, okay, yeah, so I talked about the relays, the remote control relays, and then this ridiculously big relay here, sitting here on the top. And the story on this was another special story. And I don't know if you guys have looked, but there's a big bad. I've got a big bad sticker on the top of this, breadboard. It's because about 2 weeks ago, before my last presentation, I had wires everywhere. Wires were dangling over the top. Everything was working, but the packaging sucked. It was just like not really packaged. So I decided, okay, I want to package the wires inside here. And of course, one of the problems with this linear actuator is, what are you going to do with wires? You can't put just straight wires in there, right? They're going to bind up. They're not going to work. So, you guys look in there. I don't know. It's probably too hard for you guys to see, but what's inside is coil wire. Yeah. So after spending a little bit of time thinking about it, I came up with the idea of using a coiled wire. So, okay, that's cool. But finding coiled wires is pretty tough. You go to Fry's, there's really no selection or anything. And so I was like randomly ordering wires on Amazon, just trying to get the right height and the right thickness and stuff. And so I finally, kind of set something up, and I put a pretty thick one in like this. And this one I'm returning. So, but I ended up getting wires that are pretty thick, and it turned out that I sort of cheated on my electrical engineering side with the relay. So there's a real big power relay that actually drives this thing up and down, that actually switches to 12 volts off and on in order to drive this up and down. This takes a lot of power. And I bought one that was 2 amps because it was what Fry's had, and it was like the right form factor I needed. And I really needed 5 amps, but I got 2. So I finally, when I installed the really thick wire and I ran it up, it stalled. So it made it like halfway up, wouldn't make it the rest of the way, sucked the full 5 amps, fried the board. so that ended up frying. I thought it fried the relay. Interestingly, it actually fried the breadboard. So the wires inside the breadboard actually smoked and fried. so anyway, to make a long story shorter, I got rid of some of the big wires. I replaced this with a truly accurate full 5 amp. I think this is actually a 10 amp relay now, so it can fully deal. I put wires in that were big enough because some of these wires were not really, I mean, they were like, yeah, you could smoke them if you really sucked 5 or 10 amps through them. So I put big enough wires on in order to make it work, and replaced that with telephone. Right? This is really cool. This is great. So I installed that, got it all going, it's great. But the servo didn't grab well enough. It moved slowly. Didn't grab the mailbox because the resistance of this thin wire was not good enough.
It's too much.
Yeah. So this was too high. This was like 6 ohms, which is kind of ridiculous. I don't know what the deal is with that. But this is like a telephone handset wire, 4-wire. And this is like 6 ohms, which is ridiculous. And I really need, like, these other ones are like 0.6 or 0.4, which is what you need. So my last demonstration, I used this. It actually didn't work very well because it wouldn't hold it tight enough. So this is like flopping around. It's not really being held very well. So I finally went to what randomly works sometimes, Radio Shack. And they actually had this wire that I'm currently using, which is yeah, no, my local one isn't. It was a locally owned one. But I finally found a cable just the right length, low resistance, works great. It's it does what it has to do as far as extending, and it works great. But there are these sometimes just these kind of oddball problems that happen.
That's how you learn.
That's how you learn. Exactly. And I've learned way more than I ever wanted to know about power. It's crazy. And if we have some time, or if people want to hang out, I can talk about power on that thing. But that was crazy power, having to reduce the power to actually run on just a solar battery. But this one wasn't so important because I have a big enough battery and whatever. But anyway, so that was that. And this is the packaging, and it's kind of in a pretty nice state, I think, as far as packaging. I mean, ultimately, I'm going to drill holes in the side and mount connectors like I did on this, right? I mounted permanent connectors that go from the inside to the outside, so everything will be sealed, weather sealed, and everything.
So what's the sensor up there? Is that a micro switch?
Yeah, a little micro switch. These are great. I ordered a bunch. I mean, some of these switches are kind of ridiculous because you can, buy some on Amazon for, $10 or $5, or you can order them from China, where you have to wait from Hong Kong, where you have to wait for 3 weeks, but it's like, $5 for 50. Exactly. So I've got 50 of these switches now and 50 of another kind. But these are just little lever switches that turn out to work really well. So I got a switch there and a switch down here. That's how it detects that it's driven up and it's actually made contact. So there are the 4 actuators, the 2 motors, the linear actuator, and the servo, and then 2 inputs, 2 switches. So this switch here and that switch there. So it can actually tell that it's both mated to the bottom and it's also mated to the top.
How did you debounce your switch? Did you do it in software?
Yeah, software. Yeah, I just sample it fairly slow. 10 milliseconds or something. It's fine. Yeah, so that's probably mostly the technical aspect of this. Sure.
Non-technical. Where did you find the box?
Radio Shack.
Yeah.
Yep. No. This is another case. It's so funny
What's
because
that purpose as? What's its normal use?
no, it's a box. So it's a
just
project.
box.
It's a
It's all
project
in a
box.
box.
It's just a project
Yeah.
box. Yeah,
Yeah.
it just comes and there's screws and there's an aluminum, deal.
Marshall's hardware.
Yeah,
so
and it's random because
Fry's has.
well, Fry's. Yeah, see, I usually go to Fry's for that stuff, and they have a big selection. But the Fry's prices were super expensive, and for some reason, this was like $8 at Radio Shack. So I'm like, so Radio Shack, it's like really random. Sometimes it's really good, and sometimes they have what you want. But so Fry's is fine too, though mostly.
Is that waterproof? That one?
No, probably not.
Sure.
But
Okay.
later I'll have to do more to make it waterproof. But no, but it was a good
Sounds right.
closure. You just gotta get it.
Home Depot.
What's that?
Heavy plastic.
Yeah,
Waterproof. No problem.
yeah, and yeah. So I'll think about some more of that. But you just want to have it packaged in a way that you're not wires shorting out and doing other stuff. So it's just like worth doing that.
110-volt stuff. They're great plastics for electrical parts. You can get some pretty nice boxes. They're pretty
Where?
Home Depot.
Oh, really?
Yeah. They're actually electrical NEMA certified.
Right.
Huh?
And waterproof.
Yeah.
So you start
You got a rubber seal that it's reusable, so it's pretty good.
Okay, there you go. So
Generally, you put the box upside down.
right.
All holes come out the bottom.
Right, that's what I did with this one. So I made sure everything was, all the connections are on the bottom. It's all, yeah. So, any more questions about the robot?
Go ahead, Mark.
I
Yeah.
want a question about
It's okay.
You can ask any
question's
question.
Fine.
Yeah. You get a free pass. You should use it while you're,
So yeah, this remote control was so nice because I originally had it set up where I was pushing buttons in here to make things, but for debugging,
And
because
how does the remote control work?
I have no idea.
Oh.
It's like I have no idea what frequency it is. It just came as a package. You get the remote, you get this
it has-
board.
oh,
Yeah, this
okay,
board
it
with
has
cert, and you just boom.
Wow.
It's
So
yeah.
it came with the board.
Yeah, came to
Oh, okay.
literally.
Oh,
I
okay.
think it was like $11, which is just
that off of
ridiculous. Amazon.
So what kind of thing?
I don't
Wow.
know. It's good enough for doing.
30 feet.
But it just made it so nice to not have to keep pushing buttons in there to do the basic.
Yeah.
You know, I can so for debugging, I can basically have the code do whatever. When I push a button, I would do something. So play around with that. 4.
Do you have that label, or is that going to roll off the table if you hit the wrong button?
It will kill me. if I hit the wrong button.
Yeah, you know.
But I remember the buttons.
So where's the little antenna for that in the box?
And it's just put just right on the board. It's just a little coiled antenna on the board, and it works just fine for for this kind of 10 feet away.
Did you
or
write
whatever.
your own Arduino software for the differential drive stuff, or did you find some kind of package?
I wrote all my own stuff. Yeah, I mean, I started with a package that was ADK based because I want to ultimately have it connect to the cell phone. But then I found a lot of that stuff was completely superfluous for this test mode stuff that I was doing. So ultimately, over time, I just kept ripping more and more and more of that out. So it's pretty much 85% my own code at this point. It's not hard.
So you're using relays to turn direction. So when you click a relay, you got full power to the motor.
No, not these. No, I'm controlling these through PWM. So I have
you
fine.
have a driver in there.
Oh yeah, I have software driver. Yeah, I have software so I can finally control these motors. And in fact, I can finally control this motor if I want to also. But ultimately, it turned out that for my purpose, all I needed is it all the way down, all the way up. So I did that. And I actually have potentiometer feedback from this that I can use to tell its current position, which I played around with, but I haven't needed it. So yeah, so for this, I mostly just turn on or off. For these, I finally control. And same with this, I finally control, although, again, mostly I have it all the way open or all the way closed, but I have full fine control over it.
Does the pedestal lock, or does it just sit? Does the mailbox just sit? I'm sorry, I'm getting back to the pedestal. Does that lock?
Yeah, no, this will be rigidly attached. So this will be rigidly attached to the bottom of the mailbox. So the mailbox itself is all connected to this. So this is just a proxy. This is just a proxy for the mailbox.
Oh, I see. Okay.
So yeah, mailbox is rigidly screwed onto this base.
But the servo hill locks it.
That's what I was getting at.
Oh, that part?
Yeah.
No, it doesn't lock. There's not a no. It just let's make sure it doesn't drive off the table.
Sorry.
So yeah, no, it's just using its own power, which is why I had that problem with power when I talked about it, where I was using these. There wasn't enough power with a thin cable. It didn't hold it rigidly, but with a good cable going up, it actually holds it rigidly enough. That's good enough. So there's no like snap lock or anything. It's just.
It is locked in place.
It's held in
drove-
place. I mean, if you actually go and you go ahead and touch it if you want. I mean, or listen.
No, I understand.
So it's like the servo is actually
Right.
doing its job to try to hold its position.
Right.
It's just but it's just using what power to do
Okay,
it.
so the servo is actually drawing some power then.
Servo in this case is actually definitely drawing power. But I did design the software so that after it drops off the mailbox and backs up, it completely turns the servo off. So it's not. It's floating. It's floating in that case. But when it has to, it's definitely holding.
Are you sure that does the battery have enough power and the structure have enough enough power to lift up the weight of the mailbox and everything?
That's a good question. No, I don't know.
Somebody mails you a cinder block.
Next phase. Well, and I have definitely thought about the issue of if there's too much weight in there, could the thing fall over? Because my driveway is a 15% grade, so I've thought that I can always use if I need to, if that's an issue, I can always have it driving with the mailbox uphill, right, forward or backward, either way. The mailbox can always be uphill to keep it from falling over if necessary. But no, I haven't done those tests yet, so that's coming.
15% grade?
Yeah.
That's steep.
It is, yeah. 100 feet.
It says 100 feet over.
100 feet drop over 700 feet.
Yeah.
Yeah, it's a serious. I didn't think I could mountain bike it until a buddy of mine did it. And I'm like, damn, if he can do it, I can do it. So I can mountain bike it now, but it's work. Hey, what happened to my Racer 5s? Oh, here they
Oh,
are.
I left them over here when you.
I have another beer. There's one more for someone else. So yes, go ahead.
So have you actually tried to mount it on and see if the mailbox itself, without any mail?
I actually haven't done that yet. No, so that's no. There's. You're right. There's more work to be done.
Because I mean, if it still works, you're pretty much good unless somebody sends you a rock.
Right. Well, exactly. No, exactly. You're asking a really good question. And number one, I'm not going to use a mailbox this big. I'm going to go back to a regular size mailbox because yeah, I don't want. If I order books from Amazon, the books could be too heavy. So that's one thing. And the other thing is I've always had in mind from the beginning, because I knew it was a risk having a structure that's this, seemingly flimsy, although it's actually pretty good. I've always had the idea that I can put a second post here for it to slide up. So this one wouldn't have to be powered. So this one's powered, but this one would just add stability. So if I really have to, I can add one here or one on the back to add stability.
Yeah, but then they both have to go up.
They will go up and down. They would go up and down exactly like this one, but they wouldn't have to be powered.
Oh, they will be gripped to the. They will be gripped.
The other ones would just slide.
They
Yeah.
will be gripped to it.
They would be attached, yes. So just like this one's attached here, I would have one attached here on the bottom so that they would slide freely, but be sort of have some rigidity to them, so that that could support. Could put a second motor if I needed to, but I would think that I always thought kind of that would be a backup if I needed to add that. So we'll see. So yeah, I know I do need to go there. You guys are asking really good questions. I'm gonna have to go back. I'm gonna have to answer those. Those are really good questions. So I'm
Gary,
impressed.
instead of just putting a bar, you could put a lift gate strut.
Oh, which?
Lift gate strut. It will give you the possibility of lifting more weight.
What is that?
Spring loaded. You know, like when you lift the lift gate in the back of a vehicle, the struts that hold them open. You can put one of those.
You know, like
And
when
it'll
run an
give
SUV
you
or
some
something
weight
like that,
capacity.
or an
It'll
SUV
extend your
has this
weight
pneumatic.
capacity.
Oh, like a pneumatic or
Yeah.
hydraulic.
Yeah, they're just
Oh.
loaded with gas inside, and they,
Gas spring.
I see.
yeah, so they have some load capacity.
As long as
themselves.
they didn't provide too much resistance for pulling it
We're
down.
worried about
Right.
Well, you got
ordering
gravity to help
cinder
you.
blocks.
I know.
Yeah, you got gravity.
Yeah, we're
Just
just concerned you're not thinking of like when you get those lead batteries.
Yeah. So yeah, so
This should work fine.
I mean, yeah,
That
basically
move a
worked
lot of
fine. It
weight.
was a good demo, and the mechanical parts of it were fine, and the electrical parts worked, and I got all the servos and stuff to, I mean, there's a lot of learning and figuring out. It's like, who knows what size of linear actuator you need to get? You know even where to find one.
If you reach your weight problem, then it's more of a friction issue. So you can put Thompson bearings in here, and then that friction will go away. And this thing here, if that lives 400 pounds, I don't think you're ever
it's
gonna
more.
get a mailbox.
No, this one's only
ever-
30 pounds. This is
Oh,
geared
30
to be
pounds.
30, yeah, because it's fast. So I think the main question will be, is this going to stress the structure too much, or is it going to cause it to, fall over? But I think
Well, you
with
can
just
calculate
even just
that, too.
feeling this, it's unlikely it's going to fall over.
Especially in the hill.
But that's. Yeah, or just mostly putting the weight down low. So if it turns out I need more batteries, then put the batteries down low. But yeah, that's part of working in the real world. But
The mailbox
solvable.
falls over once, you'll figure it out.
yeah,
Is version 2 the mailbox getting drone?
what's that?
Mailbox getting drone.
Oh yeah.
Just flat, huh?
I did think about having a drone follow the mailbox down to see in case it gets stolen on a video.
I noticed at the bot wars that are just about ready to go on television here in a couple of weeks, that there's several bots now that have auxiliary bots on them, and if they start to get in trouble, they launch them and they go out and harass the enemy.
Oh.
So I can't wait to see what
Yeah,
those are
that'll
going
be
to do.
interesting.
It was on Sunday. This Sunday was the first.
This
Oh,
Sunday.
already?
Yeah.
Or past Sunday was the
Oh.
first
Oh,
one.
really?
Which channel?
Just-
ABC,
ABC.
9 o'clock.
Yeah, you definitely want to record those.
What's the show?
Oh yeah.
Bot wars.
And it's a good thing they put it in a big bulletproof enclosure because one of them went flying.
Yeah, I know. I got rid of my cable too. I've just got an antenna now. You can get, you guys know you can get an antenna. It's like a sheet of paper, super thin, and you get all the local channels for
Yeah.
free. I just cut my cable totally a few months ago. So.
We did that 8 years ago.
Oh, okay.
Except if you live in a hill at the bottom of, surrounded by hills and.
Right. I live on the top of a mountain, so it's
Yeah.
probably easier for me. But
Yeah, I'm in the reverse place.
Yeah.
And it's mountain shadow.
so if you guys want, I can talk about the mailbox a little bit. 7:05,
Yeah.
so maybe 10 more minutes of the meeting.
Yeah.
Talk about mailbox. So done with the robot.
Yeah.
So
So
you should have a really visible emergency off, so someone who doesn't know anything about it can kill it in case it decides to go over a cliff or something. Or they ran over it.
You'll be able to tell because it'll catch the brush on fire and you'll see the fire.
yeah, I know. That's actually a problem in our neighborhood. So gotta be careful about the nuclear powered. So so the mailbox, I already demonstrated it. Basically, it's just the way it works is a light sensor. So there are many ways to do it. You can do it any way you want it. And again, I wanted to learn something new. So I wanted to build a self-contained unit for making the mailbox work. So there's actually a light sensor that, if you look, so I don't know if you look, there's a closely on the back. There's actually a little tiny round thing in the middle. I just had to sort of drill a hole in the mailbox, and so the light sensor is mounted in this box. This whole enclosure can just be removed from the mailbox, and it works fine. And the idea is just detects when the mailbox is open, mailbox is closed. So let's see. You have mail. And then close it. So basically, it's way more complicated than it should be. This is actually more complicated than the robot. Let me just open up the back and show you quickly what it looks like inside. So like I said, it's solar powered, internet connected, which turns out to be the most expensive part of this whole thing is the internet, the Wi-Fi board, which was $85 or $89.
There's cheaper solutions now.
Are there?
Yeah.
This was an Arduino Shield,
Yeah.
which was a convenient one.
Yeah, it's really good. They have actually, you can buy a microcontroller with a Wi-Fi shield on it for $9 now.
Oh, really?
Yeah.
Oh.
$6.
But is it compatible? I mean,
$6,
part of
they're
what I
not
like to do
certified.
is turn it on its side and flip this. Yeah.
Why is there always lights on?
Well, they're not normally on. They will turn off soon. They're only on when things get activated. And that helps to debug the system. So if you're trying to make it work, it really helps you to know what's currently being activated. But they'll turn off soon. They're being turned off now. So I don't know. It's probably not that easy for you guys to see, I guess. But basically, this is. Let's see if we can aim it.
Oh yeah.
I'm gonna try to aim it so people can see it. Just to give people a. Let's lift it up and see. So there are actually 2 Arduinos in there. If you can see, 2 Arduinos and some relays and some other things. Try to aim it the other way. We have 2 Arduinos and some other stuff. And then some other stuff even mounted on here. I have a power amplifier here with speakers that I got from birthday cards. You guys ever gotten those goofy birthday cards that talk? I have 3 speakers that I salvaged from those, and which is how the talking works. That's a power amplifier. So leave that turned all the way on. Yeah, so that allows them to be louder than they would normally. But so basically this is just kind of ridiculously overpowered for what you need. But the reason is because of power. So the basic architecture is an Arduino. I think it's an Uno. No, it's a Leonardo. So the basic Arduino is a Leonardo. It's just one of the basic Arduinos that does the core, pulling of the light sensors and whatever and controlling stuff. And then there's a second Arduino, which I think is an Uno, that has the Wi-Fi board on it and has the ability to talk. And then
There's actually 3. Here's that one.
Right, that's true. You're right. There are more boards, and this one is just a power amplifier. So this is for just amplifying the power to the speakers. The speakers are loud enough to hear, because the Arduino itself can't power the speakers enough. They're not loud enough. And then there is there's a servo that controls this, and a couple of relays. So the reason for there being 2 Arduinos, which seems kind of ridiculous, but is because of power. When I first started this project, the mailbox is at the bottom of the hill. Right? There's nothing down there. There's no power. There's nothing. So I figured, let's build something that'll run on 4 AA batteries, right, for a year. I don't want to have to mess with batteries all the time. 4 AA batteries for a year. So I set up the basic Arduino. I had it working with the basic stuff, with operating the servo and doing basic things, not the talking and stuff, but just the basic things. And I measured the power output, the power usage, and those 4 AA batteries would last for 24 hours.
Wow.
Yeah, ridiculous. And that's mostly doing nothing, right? That's the Arduino mostly just not doing anything. But the way, things are just, cycling. It's just sucking power. So I spent a lot of time with a great electrical engineering friend of mine. We went over to his place and looked at our oscilloscope and power supplies and started looking at what's really sucking the power. What can we do? And I spent a ton of time getting the power down to what could be powered by this solar battery. And what it took was, I don't remember the numbers anymore. I did this presentation earlier. But when it's powering the servo and the Wi-Fi and talking, it uses something like, I want to say 350 milliamps, which is a lot. And when it was just idling, it was using like 50, which is way too much because the batteries can only supply, much less. And I needed to get the power down to like 10, right? Which is just a big difference. So to do it, I took several steps. I stole some software, not stole, I borrowed, it's open source, whatever. Some software that worked on this board that basically shuts the board down completely, literally turns off all the power on the board except for a watchdog timer that wakes up whatever frequency you want. So I have it wake up like once a second just to do what it needs to do. And set up some interrupts so that certain things like pushing the button would wake it up immediately. But basically it really totally shut the power down. And because of the fact that things like the servo just suck power all the time no matter what, I installed the relays so that I could literally the board just turns off the source of the power of the relays and of the second board, which the second board is the one that does the Wi-Fi and the talking. So literally that board is turned off. The power is cut off. There's no way it can suck power. And no way the servo can suck power. And the main board is shut down and only waking up once a second. And that got the power consumption down to about 5 milliamps, which was
Big difference.
huge. So got it down to 5, and it would it wakes up twice a day, right? When you get mail, when you get the mail back, and it sucks 300 for like a minute while it's communicating on Wi-Fi or whatever. But it's such a small amount that the battery was always able to be recharged, and from then battery charged all the way up to full power, and it basically doesn't drop below full now, or basically pretty much always seems like it's 100% charged, but it took a huge amount of work to get that power consumption down, which is surprising and annoying. So anyway, so I don't know if that was a very interesting description of the thing, but whatever. That's why there are two. The fact that there are two Arduinos in there is because one actually physically gets turned off by the other one until it's needed. So, yeah.
If you want to keep it charging, do it up in an adapter, then I think you should put 2 generators and for the back wheels.
Could use regenerative braking, that's true. But that's not going to be sustainable, so it would need to be, the main robot will have to be charged by house power for sure. But the mailbox, I got the power consumption down enough that it could actually live with just that battery, just that little power cell, that little solar cell, which is only about that big. And it's worked continuously for 9 months. 9 months in the wild now. The only time it's failed is because of the infrastructure. So this mailbox, if you can imagine, I don't have a whiteboard, but if you can imagine my house is on the top of a mountain, and the mailbox is down at the bottom of the hill, and there's a hill in between. So the mailbox can't see the house. There's no line of sight. So in order to actually get the mailbox to connect to the internet and be able to send me a text, from my house, I had to build my office, a router up in the eaves of the house, connecting to a router down at our gazebo with a directional antenna aimed down at the mailbox. and then the mailbox is now on the internet. And the only failures I've ever had were actually the gazebo directional antenna router failed a couple times when it rains, and I get ground faults. So the ground faults knock it out, but I can turn that back on. So the infrastructure for even getting it onto the internet is kind of ridiculous. And then it goes from there. To my host, my internet host, to my cell phone.
How many million
It's a
hours
crazy,
does it
crazy
produce?
connection. But yeah,
Oh, that's
it works.
So do all your neighbors, are all your neighbors hoarding one?
What's the goal?
You know, people, every time I show it to people,
What's
and people say,
USB?
oh, I want to buy, what would you, but it's like, this is a $10,000 mailbox.
Yeah.
It's like, come on. I mean, the parts were probably $250 just buying them off the shelf or whatever, and my time was $10,000 or whatever or more. So it's like, to really do one, to really make marketable. I mean, what kind of mailbox do you have? People have mailboxes in their house, or in an apartment complex. So lots of people say they love it and they would like to buy it, but I don't think it's a commercially viable product. But this is, when you hear about the Internet of Things, this is a thing.
A question about the sensors. You say you have a light sensor every time you open the door. What is actually determining that you actually have mail? Because I mean, you could just go, someone could just come, help and close the door.
Yeah, you can just open it. There's no real determination of mail.
So are you just counting, like, when the door shuts, it resets itself and assumes that?
Well, that's actually a really good question. So one of the other super interesting problems on this, and again, as me as the geek, but I don't know if to you guys, but one of the problems with this is after I got it all built, and I'd have it in my living room, and I'd be working on it and testing it, and the light sensor, you get a value from 0 to 100, right? So you say, okay, 50. If it crosses 50, it's gone from dark to light, right? It's gone from closed to open if it crosses 50. Okay, maybe 50 isn't really right. Maybe it should be 35, depending on the resistors you use and whatever. So what's the number? Pick a number, and you get it to work, and it kind of works fine in your living room. And I go and install it out in the real world, and kind of works fine, but I found I was getting tons of false positives. I'd come home, I was always saying, not always, but often saying, you got mail. It's like, I don't have mail. What's the deal? What's going on? So I finally realized that, well, the ambient light throughout the day varies dramatically from night to, from dawn through, maybe clouds coming over through dusk. So the ambient light level changes dramatically, and there was no picking. I tried for a while just picking a number of saying if it goes past this number, it means it was open. Didn't work. So I actually wrote some sophisticated software that was a little calculus. It basically checks for the rate of change of the light. So it actually constantly monitors the ambient current light, and then it looks for a rate of change that's beyond a certain value. So if it's dawn and it's barely light at all, it might be down at 5. But if it changes up to 10 really quickly, that means it was opened. During the day, it might be noon. It might be at 75, even when it's closed. And then if it changes up to 90, then that means it changed. So I actually had to write some software to actually track ambient light throughout the day, and now it's worked flawlessly since then. And that was actually pretty interesting problem to deal with. And if you look closely, you'll see I actually put tape covering up all the little holes in this thing to try to make it completely dark inside. But there's no way in a mailbox to make it dark inside. So anyway, I don't know. Any more questions about the mailbox?
So maybe we'll wrap it up here, Gary. If you have like 5 or 10 minutes, maybe we'll just keep you. And then if you have any questions, maybe you can ask Gary after. Thank you very much, Gary.